Hello everybody, this is Mr. A again, and I have a question that I am solving. This is about motion and friction. I'm going to go ahead and read the question to you. A 12.0 kilogram box initially at rest slides from the top of a ramp. The top of the ramp is 6 meters above the ground. If the force of friction along the 11-meter long incline is 5.0 newtons, what is the speed of the box as it reaches the bottom of the ramp? Okay, so we are going to establish a few facts before we can start calculating anything. The first thing is that since we need to determine the velocity at the bottom of the incline, and we know that the velocity at the top is zero because it slides from its at rest, so there must be a change in velocity. If there is a change in velocity, then there must be an acceleration. And if there is an acceleration, there has to be a net force that is promoting that acceleration. So what we are trying to do, or we are going to do, is try to find that force that's acting on the box along the incline as it slides, and using that value of force, we will work backwards and figure out the speed at the bottom. Okay, so here is what we are doing. And I have drawn some diagrams here that I'm going to try and use in explaining what's going on. The first diagram, of course, just shows the scenario that there's an 11-meter long ramp. The box is 6 meters high at the point of start where it starts sliding, and we don't know what the angle of inclination is, which of course you'll see that we don't actually need it given the information that's given, but just for the record that we do not have the angle. Okay, so some things that I have calculated for you here, and I'm going to be moving this screen up and down because there are pieces of information that are not visible right now. They are below the screen, but I'll bring them up when we are ready to look at them. All right, so uh, on the diagram on the right, which is this diagram here, the little square, this is just a blow up of the forces acting on the box itself. So this is a free body force diagram of the box. So the box is being influenced by the weight or the gravitational force, which is mg. We have the mass, so we can find mg, so that's a known force. It's also under the influence of a 5 Newton frictional force. And then, of course, there is a force that is uh, keeping the box from falling through the incline, and that is acting perpendicular to the slope, and that is called the normal reaction. I have also broken down the gravitational force into its component parts. There is y component, which is along the slope, and there is x component, which is perpendicular to the slope or opposite to the normal reaction. So those are the three forces, and then one of them has been divided into two. So we are really just dealing with three forces, but since they are not all in the same direction, we have to have uh, the directions resolved. Reaction and frictional force are perpendicular to each other. The weight does not act perpendicular to either of them, and therefore we have to break it down into parts that are perpendicular so we can add, subtract, and so on. Okay, so that much is there. And I'm not actually reading through here. That's something I'm going to let you do, but I will be pointing out salient parts just in case there is something out here that needs further explanation. Okay, so anyway, going back to here, first of all, we want to establish the vertical force or the force perpendicular to the slope. It's not really vertical, it's just perpendicular to the slope, which is the normal reaction and the x component of the weight. Now, since we know that the box is not accelerating away up from the slope or into the slope, like it's not moving up this way, let me pull it up here. So the box is not jumping up or it's not burying itself into the slope. We can safely say that the forces perpendicular to the slope are equal, or the net resultant force acting perpendicular to the slope is zero. And so we have sigma F perpendicular equals zero. So that's something that's out of the way because that is not going to affect our calculations, but we want to be sure that it will not. And so we have figured out that that is zero. So that's not affecting anything. What we are really concerned with is the frictional force and the y component. Okay, so moving right along here, we know that the frictional force is 5 newtons. We don't know how much the y component of the weight is because those are the two forces that oppose each other and their difference is the resultant along the slope. Okay, so let's find out how much y is. Now we know that mass is 12 kilograms, and we know that g is acceleration due to gravity, which is 9.81. And so using our vectors and taking this side as the y component, which means it's the sine theta, so Fy or mgy if you like, is mg sine theta, but we don't know theta. Remember we discussed earlier that the angle is not given, so we don't know how much that is. So we take the ratio sine theta as perpendicular over hypotenuse. And based on that, we are saying that sine theta should be equal to 6 over 11. Coming back from here, that's the perpendicular side, which is 6, and this is the hypotenuse, which is 11. So the ratio is 6 over 11. And then we solve that, and we find that the y component of uh, the weight is 64.2109 newtons. Now, that is just the y component of the weight. And remember that the weight or the y component of weight acts down along the slope. And if the direction of motion is down along the slope, then the friction must act opposite that and therefore will oppose this force. We know also that the magnitude of that friction is 5 newtons, and so you have 64.2109 minus 5. So the net force along the slope is downwards, you're down the slope, and it's 59.2109 newtons. Okay, so based on that, we're saying that the acceleration now, remember we needed to find acceleration. We determined that we need to find the velocity, we need the acceleration. For acceleration, we need the force. So we found the force, and now we're using that force to find acceleration. And then the last part would be to find velocity using acceleration. So let's do this. Acceleration is force over mass because you know the equation F equals ma, and so this is just a form of that same equation. And so F we have found from here 59.2109, and then mass is given as 12 kilograms. Once we divide those, we find that the acceleration comes out to 4.9342 meters per second squared. Okay, so once we have the acceleration, we can now plug that into a kinematics equation, which is Vf squared minus Vi squared plus equals to Vi squared plus 280. Let me say that again. Vf squared equals Vi squared plus 280. Okay, so we need to take the square root of this number. That is not our answer. So let's see if I can do that quickly. Uh, Here. Oh, okay, won't let me do it. So, but anyway, I'm gonna just type it. Square root of this. And the square root of this equals to, and I will go ahead and use a calculator for this. So you have, don't see it. Do I see it? I do not see the square root of this one. Okay, let's see if the standard one has. Nope. Okay, no problem. I thought scientific calculator would have square root. I've never really tried to use it here, but that's okay. We can always use some of the other functions, but I can just use a plain calculator on my own. You can do it on your own when you are looking at it. But let's go ahead and calculate that, and that is 107.8, and then we take the square root of that number. It's 10.38. So we get 10.38 meters per second. This is not the final answer. Okay, so the square root of 107.8, because this is VF squared, so VF comes out to 10.38 meters per second. Okay, so that is what we have. That is the answer to the question of velocity. Now, I am going to go back to something earlier. I am going to explain once more why the sine theta is 6 over 11. And for that, let's look at this diagram here. Uh, so you have a triangle ABC, which is a right triangle, and then you have a triangle CDB, which is in red, which is also a right triangle. So now you have two right triangles, and the first thing we want to do is prove that they are similar, because we know that if triangles are similar, then the ratio of corresponding sides is equal. So this big triangle, ABC, is the same triangle as this one. So it has the vertical side as 6, hypotenuse as 11, and then we don't care about the bottom side because that's not needed in our calculation. And then this little triangle in red is the same triangle as this one, which is the X, Y, and the MG. Okay, so I have superimposed one on the other, and what we're trying to prove is that these two triangles are similar. That is the first goal. So if you look at triangle ABC and triangle CDB, you'll see that they are both right angles, and therefore they both have a right angle in there. They're both right angle triangles, so one of their angles is a 90-degree angle. Okay, and then this angle DCB is the same as angle ACB, right? It's the same angle. It's just exactly the same angle that we're looking at, although they are on different triangles, but the magnitude of the two is exactly the same. So now we have two triangles with two equal angles. And of course, if two angles of a triangle are equal to two angles of another triangle, then we know that all angles are equal. And if all angles are equal, then the triangles are similar. And if they are similar, then the ratio of corresponding sides will be equal. And that is why for this little triangle, we have taken the ratio of this side y to the long side or the hypotenuse as 6 over 11. And that's how we get sine theta, which is 6 over 11. So I hope that makes it clear. If you have any further questions, anything that you still don't understand, please feel free to email me. There is an email address in the about section on this video. And also, I have a little note here, so remember to read it. I offer one-on-one tutoring. If you need any help, please let me know. And I hope that this is going to be helpful. Thank you very much. This is Mr. A signing off.